Ma'am, is the screen visible?
No. Oh yeah. Now is only white color.
Ma'am,
Starting to
now,
share the content. It's not visible anything. Only white screen.
okay, ma'am, I'll reshare one second.
Okay. Okay.
Ma'am, somebody has to make me presenter, ma'am. I am unable
Yeah.
to.
I
Gunavati.
already made you a
Gunavati.
presenter. Ma'am, I've already made it, ma'am.
Ma'am, then it is showing that
Okay.
it is showing to start, ma'am, but again it is not sharing.
I just made it co-host. Try now. Because earlier I made
Yes,
it as a
ma'am.
presenter.
Now is it visible, ma'am?
No, maybe you need. Oh, yeah, it is visible now.
Yes. Okay, welcome all to the third day session of queuing theory. So today I'll explain some of the different problems that will be coming in different models, as well as I'll be explaining different model paper questions, as well as previous VTU question papers, as well as at the end I'll be taking up some of the applications where whatever we have learned yesterday, day before yesterday, that could be applicable, and how this actually the queuing theory models have been formulated in the practical case. Okay, so firstly I'll take up some problems from the model question paper, so that it is of somewhat like straightforward questions, as well as it will be something like a basic question for understanding some other advanced type of questions. So let me take the first question. So this is the question related to a telephone booth. So I'll read out the question first. Arrival at a telephone booth. So before that, I'll tell it is a model paper 2 question, module 5, question number 9C. It was asked for 7 marks. Okay. So arrival at a telephone booth are considered to be poison with a average time of 12 minutes between one arrival and next. So between one arrival and next, it means they have given inter-arrival time. So inter-arrival time is given as 12 minutes. The length of the phone call is assumed to be distributed exponentially with a mean of 4 minutes. Length of the phone call is given. That means it is an inter-service time. So again, inter-service time is also given. So in this question, they have given inter-arrival time as well as inter-service time. So find the average number of persons waiting in the system. So what is the probability that the person arriving at the booth will have to wait in the queue? Then what is the probability that it will take him more than 10 minutes altogether to wait for the phone and complete his call? And further estimate the fraction of the day when the phone will be in use. So this is a question. So as I told in yesterday's session, first step in solving the question is that first identify which model is this. So you can find that arrival at a telephone booth. At a telephone booth, it shows that there is only a single server. So one server. So you can conclude it as MM1. Next. So nowhere in the question they have given that arrivals are restricted from entering into the system after particular arrivals. So it means that it is an infinite capacity. So MM1 infinite FIFO model. Okay. They are already given what is average time, inter arrival time, as well as inter service time. So first I'll take out the data. So it's in a given problem, server is a telephone booth and arrivals as well as service rates are Poisson distribution. So okay, it's given that average time of 12 minutes. Okay. So the thing what actually happens, I have shown in this flow diagram. So this is a service which is shown in a green color, and this is a queue 1, 2. Now the first person is the one who is now taking the service. and second person is the one who is waiting in the queue. And once the first person reaches the output, that means he goes out of the system, the second person will presume the work that first person is presently doing. So this is what happens. So this identification of model I already told you. So it is MM1 infinite FIFO model. Okay. So after given this, so I told it is inter-arrival time. So average inter-arrival time as well as inter-service time is given. So it means 1 by lambda and 1 by mu is given. So 1 by lambda given as 12, you can find lambda. 1 by mu is given as 4, you can find normally mu. So next is um, capacity utilization. So once you know lambda and mu, you can easily find what is your capacity utilization rho. It is lambda by mu. So it is 1 by 12 divided by 1 by 4, it will be 4 into 1, it is 1 by 3. Now, the given first question is that what is the probability that person arriving at a booth will have to wait in the queue? See, the person have to wait in the queue means, so in this flow diagram, you can tell that if a person is not a number one person, then he has to wait in the queue. That means when the person arrives into the queue, there should be no other person in the system. So then only he can straight away take up the service. So it means simply it is 1 minus P of W equal to 0. W equal to 0 means the waiting time in the system is 0. So that means there are no customer in the system. Then only it is possible. So it is simply 1 minus P naught. So we know that P naught is 1 minus rho. So this will be 1 by 3. So probability that person arriving in the booth will have to wait in the queue is 1 by 3. So this is the probability of waiting in the queue. Second question I have given here only. What is the probability that it will take him more than 10 minutes altogether to wait for a phone and complete his call? That means they are telling that the waiting system, the waiting of a person in the system is greater than that different values. You are getting 0.188. That means the probability that it will take him more than 10 minutes together to get out of the system is 0.18. So next, so they have given one sub question that you have to estimate the fraction of day when phone will be in use. So that means when phone in use means there is at least one person or one customer who is in desire of service. That means you have to subtract when the phone will be in idle. So 1 minus probability of phone will be in idle will give you the value of the probability that phone will be in use. So it is 1 minus P naught. So you will be getting 1 minus P naught, again P naught is this, so you will be getting the value as 1 by 3. So the fraction of the day when phone will be in use is 1 by 3. So this together will compose you 7 marks. Only this is the solution. So a very simple solution. So it is given 3 different sub questions. So in the first one, they are asking the probability that the person arriving at the booth will have to wait in the queue. And so to the surprise, in this question, queue will be there. So that means, so almost same. They mean the same. So the probability that when phone will be in use, and here it's given that probability that person arriving will have to wait. Yes, if the phone is already in use, then the person who arrives into the system has to wait. So first and third one remains same. So okay, next question. So this one I'll go in a faster manner because this question with almost 10 to 11 sub questions I have explained in yesterday's session. So the same question with only 3 or 4 they have given here. So again, one man barber shop, inter-arrival time and inter-service time is given. So expected number of customer in barber shop, LS and LQ they are asking. You can straight away take the formula of LS. So this is almost same. So here one man barber shop, it is one server and there is no restraint of entering into the system. So it is an infinite capacity. So MM1 infinite capacity FIFO model. model. So now, inter-arrival time 1 by lambda is given, inter-service time is 1 by mu given. You can find lambda and mu from that. And first they have given LS. So in some of the text they'll give E of NS or LS, both mean the same. It is expected number of customers in the system. So here it is lambda by mu minus lambda, you'll be getting 5. Next, similarly, it is Q, E of NQ, there is a correction. So it is E of NQ or LQ. It is lambda square by mu into mu minus lambda. You will be getting 4.1667. So this is the first question they have asked. Now coming to the second one, it is given that calculate the percentage of time an arrival can walk straight into barber shop without having to wait. So by now you are very familiar with these type of framing. So when an arrival can walk straight when there are no person in the system. So that means it is simply 1 minus P naught. Yes. So you'll find rho. So you find P naught. Sorry, it is P naught because there should be no customer in the system. It is P naught. It is 1 minus rho. You have found the value of rho. So you will be getting the value of P naught. It is 16.667%. So here the question was that arrival can walk straight into barber chair. So there in the previous question it was arrival have to wait. That means 1 minus P naught there. But here it is directly P naught because there is no person in the system. For that probability will be P naught. So this one was that. So next we'll see third question here. So how much time can a customer expect to spend in the barber shop? So in the system, what is the time he is expected to spend? So they are asking WS. It is 1 by mu minus lambda. You'll be getting 60 minutes or 1 hour. Here you can even apply little la, that is also correct. So you know that little la LS is equal to lambda into WS. You know already the value of lambda. You can find, you know already LS, so you can find E of W from that also. So that's all was the question. So this is again a 3 sub questions and it is asked in for 7 marks. So the thing is that in the first they asked for LSLQ. In the second they asked for what is the probability that an arrival can straight away take the service from the system. So in the third one again they asked what is the expected time a arrival has to spend in the system. So this was the question. So next I'll take third question. If I'm going speed, you can stop. So I'm going in a normal speed because that question was already been explained in detail in the yesterday session. Okay. So this I'll go little slow because it's not MM1 infinite FIFO model. It is a another new model. So I'll tell that. So here we'll identify question in detail. So it was the question from model paper 2, module 5, 10B. Okay. So patients arrive at the clinic according to Poisson distribution at the rate of 30 patients per hour. Now the question is what they have been asked. Patients arrive at a clinic according to Poisson distribution at a rate of 30 patients per hour. So it is not inter-arrival time. It is the mean arrival rate. So in this question, they asked mean or average arrival rate. So it is straight away you can take it as lambda. You no need to take it as 1 by lambda. So next, the waiting room does not accommodate more than 14 patients. So in a waiting room, only 14 patients are allowed and one patient will already been taking the service. So that means in the entire system, only 15 patients are possible to accommodate, not more than 15. So it's given in clear. They have not given the system does not accommodate. If they have given system does not accommodate, then only 14 patients. They have given waiting room. And if in waiting room 14, then one person will be already taking the service, right? So you should take 15 patients. So now examination time per patient is exponentially with mean rate of 20 per hour. So they have given examination time per patient. Okay, so is given with an exponential with a mean rate of 20 per hour. So that means mean service rate is given 20. Okay. So they are asking three things here again. Find the effective arrival rate, lambda dash, effective arrival rate, and what is the probability that an arriving patient will not wait, and what is the expected waiting time until a patient is discharged from the clinic. So now we will see first step is model identification. So here they have given at a clinic according to Poisson distribution and waiting room. Here nowhere they have given about the server. So you can take it as one server. So because they have given just waiting room does not accommodate more than 14 patients. So they have not given how many doctors are being operated in the clinic. Correct. So you can take it as in one. So it is MM1 model. Now, so they are telling waiting room does not accommodate more than 14 patients. That means you leave about the patient who is taking the service. Now, if the 14 patient has arrived in the waiting room, then until and unless one patient get exited, no patient will be allowed to enter the system because the capacity of waiting room here is restricted. So it is not infinite FIFO model, it is KFIFO model. Okay, so this one we have got. So we have got the value of lambda and mu also. So I'll be noting here. So the thing is here very simple. So a service is there. Now suppose this queue of 2, 3, 4 like that it goes till 15 because one is taking the service and other 14 are waiting. Now if one exists from the service, then only the new one can come. So this is MM1 KFIFO model. Okay. So as I told here directly they have given the value of lambda and mu. Please don't confuse with 1 by lambda. Here you have to understand the question that they have given the Poisson distribution at a rate of 30 patients per hour. So Poisson distribution will be always nothing but mean arrival rate. So it is lambda directly given as well as the examination time per patient is exponentially with a mean rate. That means 1 by mu with a mean rate of mu. So directly they have given value of mu. It is 20 per hour. So this you have to remember. So here given. As I told K you should not take 14 because K is nothing but what is the restriction in the system. So in the system restriction is not 14. In the queue restriction is 14. In the system 14 plus the person who is taking the service. So it is 14 plus 1. So K is nothing but 15. So it is MM1 15 FIFO model. That's it. So that means capacity is 15. Okay. So now you find what is capacity utilization. So as it is an end of the session, when I take the application regarding this, I will explain in detail what is capacity and capacity utilization. Okay. For now, you know capacity utilization is the ratio of lambda by mu. You'll be getting the value as 1.5. Okay. So yesterday I have given the PDF from slide 38 to 62. If you have gone with different formulas, you can now open MM1 KFIFO model. So there you have the value for P naught and in terms of like lambda equal to mu, there is one formula, and lambda not equal to mu, there is one formula. So now we will be taking here as lambda is 30, mu 20. Lambda is not equal to mu. So you are having 1 minus rho by 1 minus rho to the power of k plus 1. You substitute, you get the P naught value. Now, so why we need effective arrival rate? So why we need effective arrival rate in case of KFIFO model? So what happens? So to explain that in detail, I will be taking whiteboard. So then I will come back with this slide again because you have to know why in the previous problem of MM1 infinite FOFO model, why we have not taken this effective arrival rate, and why in this problem they are asking effective arrival rate in spite they have given what is mean arrival rate. What is that difference between average arrival rate and effective arrival rate? So the next 5 minutes, please to concentrate on whiteboard. I'll be sharing now. Concentrate on whiteboard. I'll be sharing now. So 1 second. Yeah. So yeah. So I'll be taking up. Huh? Yes. So lambda. Lambda was, you can take mean or average. So it is mean arrival rate. Yes. So they are asking lambda dash, that is effective arrival rate. So now, why that comes only in the picture of KFIFO models? Not only this, in MMS KFIFO model also, you will be getting this lambda dash. So I'll be telling here only for both. So now, say for example, you have lambda is the mean arrival rate. Yes, lambda is the mean arrival rate. That means lambda is the arrival rate of arrivals into the system. Yes. So, okay. Now, in the present problem, the waiting room is having the 14 capacity, correct? So, now, if only one person is waiting, then with this arrival rate, the person can enter. So, now 2%. Now again with the same rate, and another person can enter 3 and so on. Now the 14th person will enter with the same arrival rate. Correct? Yes. Now what about the case of 15th person? The case of 15th person will not be the same of his previous one, that is 14th person, because he was having a provision, he was having a space to go and sit in that waiting room, but 15th person can't. He should just see the system and come back. He is not having right to enter the system. What he need to do? He need to wait until the person who is taking the service, or you can tell number one or first person who is taking the service has to take the service and leave. Then in the waiting room, out of 14, one will enter the service room. Correct. So now 13 has happened and now he can enter. This 15th person can enter the system. So is here the rate has changed? Yes. So the average arrival rate has changed here due to the restriction in the capacity. So that's the reason why. So you have lambda dash. So it is nothing but the effective arrival rate. So considering both the things, both the case still the capacity is available, and after the capacity has got over, what is the probability? So you will be getting the value as lambda dash. And that is given as a formula. Lambda dash is equal to mu into 1 minus P naught. Why are we are using mu? Lambda dash is always directly proportional to mu, because with what rate there is an exit from the system, or there is a service rate from the system. What is that rate? So it depends mainly on the lambda dash. So as the capacity is just 14, so how early a doctor can treat number of patients and he sends away, and you can come and accommodate. So this is why you are given with this formula. Lambda dash is equal to mu into 1 minus P naught. Please do remember this. Why we are using lambda dash? Why not lambda here in the case of KFIFO model? I'll be going back to the PPT now. So hope you have got clear continuation of the problem. 1 minute, it is loading. So yeah. Okay. So here you need to find effective arrival rate. It is lambda dash. So I have given formula mu into 1 minus P naught. You already found the P naught using the formula. It is 20 into 1 minus sum. That value will be getting 19.9848 per hour. So See, lambda, it was 30 per hour, but now it is 19.984, right? Per hour. It is due to the restriction that is being levied on the queue length, correct? So that's what the thing is. Okay, so that is clear. Now, what is the probability that patient will not wait? Correct. So probability that patient will not wait, again it means that there is no patient in the system. So if the patient arrive, we can directly go to the doctor. So that's the thing here. It is P naught. Again, we have already found P naught here, the same value will be getting this answer. So the probability is very least 0.0007624. It's a probability. Okay. So next, it is asked to find, that means for particular problem that is given, so you will get very least chance of going and meeting the doctor directly. That's what you will be getting from this problem after solving. Okay. So next is, it is asked to find the effective waiting time until the patient is discharged. Okay. So the question is that what is the expected waiting time until the patient get discharged from the clinic? So it is the waiting time in the system. So here you can use little a. So you can't directly find waiting time in the system. So I'll be finding what is the average number of customers in the system. So that is LS, or you can tell E of NS. So for simplicity, I have taken E of N. It means E of NS or LS. I have taken different problem intentionally because any notation can be taken, that is correct. As well as you should not get confused with any of the notation. So that's why I have taken for different notation. So it is LS, E of NS. For this problem, you don't need to deal with E of NQ. So I have directly taken E of NS as E of N and solved. Okay. So this is the formula you have. In the next coming slide, in my own handwriting, I have solved. That one is there. So you can use, because while typing, I was unable to get it down. So in patience. So here you should not anywhere use lambda. Though they have given, you should not use lambda. You should use lambda dash. In little we know that E of N is equal to lambda into E of W, but in this question it is lambda dash into E of W. So you get E of W is equal to E of N divided by lambda dash. So you'll be getting 39 minutes. So you'll be getting 39 minutes here. So this is the question. So now the same question here I have written in my handwriting. So the important thing you need to notice is that how the formula actually is. You can take a screenshot of this P naught formula. This is actual formula. So in handwriting you can notice 1 minus lambda by mu whole divided by 1 minus lambda by mu power of k plus 1. Here k was 15, so 15 plus 1 is 16. So this is how you find P naught. I hope this is very simpler to understand than that previous one type. Okay. So you have effective arrival rate, lambda dash is equal to mu into 1 minus P naught. Okay. So lambda dash 19.98 question. Okay, so you'll be getting this one. Okay, so you are getting nothing. You can note the formula of E of N also. So this is actual formula. So if you go in that the one which I have typed, it was confusing. So you can take a screenshot of. Okay, this is how you find 13 patients nearly. Right. Okay. So before going with the next level of questions, I have a very interesting question where you need both the models to solve a single problem. Okay. So like for example, I will take whiteboard again to explain what is that condition. Okay, I'll be taking the whiteboard. So you already know in the first lecture of this queuing theory, I explained different forms in which the service is possible. So you are having a single server, or you may have the multiple server, correct? So now, say for example, you are having a single server and queue is formed. Now you have a multiple server and there is a queue, so that you can either join this queue or this queue. So you enter, you can join either this queue or this queue. Correct. This is nothing but multiple server in parallel, and this is nothing but the single server. Now, say for example, in your real life situation, you come across with the case where you are given with a provision. This is first one, this is second one. You are given with a provision. So there is a single server, you can go and take the service. The same service is provided in parallel and there is a queue. Which you will choose? How will you decide this? So it is interesting, right? So here you need to compare between two different models. So say for example, this is MM1 model because one server. But this is not MM1, MM2 because two servers. Though capacity may be infinite, finite, that will also, if that also come into picture, then your problem will get still more complicated. So some place you are given a restriction and some place you have an infinite capacity. For now, you consider this is the only case. So first one MM1, MM2. What will you choose? You can't directly tell. You need some computation. So I have one problem that will clear your problem or that will clear your doubt regarding this one. Okay, so now I'll take that problem. So 1 second, I'll be sharing that. Yes. 1 second, I'll be sharing that. Okay. Yeah. So this is the question. You can note. I'll given an average. Please do listen because this is different than the one we solved in the previous cases. Please do listen. Given an arrival average rate. Again, given lambda only, is it not? Because average arrival rate is nothing but the mean arrival rate lambda, which is equal to 20 per hour. So, is it better for a customer to get a service at single channel with mean service rate of 22? Mean service rate of 22 is nothing but average service rate. It is mu. Mu is also given for first one. 22 customers per hour, or at one of the two channels in parallel with mean service rate of 11 customers per hour for each of the two channels. Now, if you are not having a knowledge of queuing theory, then if you are in a straight manner, then you can think like, is it better to go in a parallel manner, right? Because there are two queue, you can just distribute among yourself. You can go in any one of the queue, and you can get the service faster. But actually, the case is not that. So you will understand that after you have been solved this problem completely. Okay. So now the data is clear. You are given with a lambda and mu for the first case and the second case. Now we'll take for a first case. If you take first case, there is a single server. Is it MM1 model? Yes. Assume it is infinite capacity because both the case they have not given there is a restriction. So both are infinite capacity. So in MM1 model, you need to find what is the waiting time. Correct. See, when you can decide a customer has chosen a better choice of going into something, it is not when there are number of systems. See, if in a first system there are 10 people, if in a second system there are 20 people, you can't tell that you can directly go to first system and join. In actual case, when you have two different counters and in one counter you have 10 people, in another you have 15 people, you directly join the one in the 10 people. But what if in the same queue length person who is operating or who is giving ticket is making delay in, for example, taking a change from you, he is making somewhat delay, then you will be done with a wrong choice. So whenever you tell some choice is a better choice, you have to go with the waiting time in the system. Okay. So here after this is the main important thing. So whenever you are making a better choice among any two of the option, you always go with the waiting time, not with the number of customer. Because if you go with the number of customer and you go only where there are only 5 customer and that server gets down, you need to wait more than when there are 15 customers. Correct. So that's why you always take what is the waiting time in the system. Okay. So here for the first one, for a single channel service, you have E of W, that is 1 by mu minus lambda. You go with the MM1 formula, you apply, you are getting half an hour. That means now if you go with a single channel, for a service you go with a single channel, you need to wait half an hour. Okay? Yes. Right. Next. And one more thing, while you are making better choice, I told make with waiting time. Then what waiting time? Is it waiting time in the system or waiting time in the queue? It is always waiting time in the system, not waiting time in the queue. Okay, right. So I hope why this is you already know. If you don't know, I'll explain it at the end. Okay. So it is waiting time in the system which you need to take into consideration. It's half an hour. Now let's see for two channel service. The channel are two. Then you have to go with MMS. Correct. Yes. So that's why I have chosen this problem, because this problem will help you in understanding how to solve MMS problem, as well as it will also help you how to just deal with the questions where they ask you to find what is the better choice for a customer, so on so. Okay, right. So now for two channels, they have given mu is 11 per hour and lambda is 20 per hour. This is the EW. So what the PDF I have shared, in that all these formulas are there. So you can just substitute in that formula 1 by mu. S is 2 here because there are two servers. So lambda by mu, everything is done. Okay. So you'll be getting the value and P naught inverse. So this formula is also there. Suppose by chance MMS model for problem has been arrived in your exam, you should be very cautious, because all the formulas in MMS are big only. You need to remember. Okay. So you can't go with the derivation, because if you want to go with the derivation, you should come from the difference equation, and you may end up in wasting your 20-25 minutes time in the exam. Be way positive. Is the P naught Pn, then you have to derive what is E of Ns, Nq, everything. So it is not possible. You have to remember. Okay, so this is the formula. So you will get the value of P naught as 0.0476. So this is the equation 2. Now you substitute in equation 1. So you'll be getting values 0.5236. Yes, here you can understand. Suppose if I have made, there is a parallel. So if I go in that system, I will be having provision. I can choose among any two queue, any queue I can go and join. So let me go with the parallel system. If I have done that thought, then that thought was completely wrong. Correct. Because there it was 0.5 hour. Here it is 0.5236 hour. Is it not? So always you go with the waiting time in the system. So to explain that single point, I have taken this problem for you. Okay. So the average waiting time in a single channel service is less here when compared to two channel service. Then why you go for two channel service? You can wait in a single channel service. Correct. So this is the case. See here in this problem, this is a basic level of problem. So they have not considered how the pattern of service is there in different channels. That is not being taken into consideration. For a basic level, you just compare with the waiting time and you can take the conclusion. So this is the question is. I'll be back to PPT again. Just a minute, it is loading. Okay. Yeah. So now you have understood different model paper problems and what are the different possible ways in which problems are arrived. Now the one who are students here, like who are about to write your exams, you need to know how your previous question paper was. So I have included this, and the one who is like has already completed everything like exams, everything, and listening for the knowledge point of view, I'll be keep on adding some important points in between, so that would be helpful for you. Okay, so let's jump into the problem of previous year. So these are all problems from 2022, the batch when I also have written the exam. So, and this is the question which in fact I have also attended and done. So okay, question number 1. So it is almost same to the model paper question. Only thing is one or two subpart is added or removed. You can see average time 12 minutes between arrival. So they have given inter arrival time, that is 1 by lambda given and 1 by mu given. So they are asking different four cases. So I'll directly go into the system because it is already been explained a little minute ago. So okay, so again these all things are same. So you have identified it is MM1 model. because there is a single telephone booth and there is no capacity restriction. Okay, so it is a MM1 model, right? Next, so you can take average number of person, E of n, it is lambda by mu minus lambda. You'll be getting 0.5 customers. Next, second part is that probability that person will have to wait. That means 1 minus P naught. Directly I'm telling because the same part was already there in model paper. So 1 minus P naught. So you'll be getting the value. Now, probability that it will take more than 10 minutes, that is P of W greater than T. And here T is 10 minutes. Substitute in e power minus mu minus lambda into T, you'll be getting the solution. Okay. So one more thing that is extra added here and very interesting and important part. So actually, in fact, this was even missing in your yesterday's session when I did different things, because as it is your previous year question, they have added something extra. We'll see what it is. The average length of queue, please do listen to this because it is completely different. So the average length of the queue that forms time to time. Okay, what is the average length of queue that forms time to time? That is the question. The average length of queue, when the queue will be formed, when there are some person in the queue, isn't it not? Yes. When there are some person in the queue, then only there is an possibility of forming queue. If there are no person in the queue, a person can straight away go into the system and can take the service. Correct. So that means E of NQ they are asking, because length of queue, E of NQ, provided with the condition that NQ should be greater than 0. This is the question. Yes. So it is not direct E of NQ. If you have done E of NQ directly, it is completely wrong here. It is E of NQ provided NQ is greater than 0. Yes. So, okay. So, for NQ greater than 0, is it not N greater than 1? Because if NQ is greater than 0, the one person will already be in the service, correct? So, it will be N greater than 1. Okay. So, that is the thing. So, E of NQ for a condition that N greater than 1. So, E of NQ for a probability that N greater than 1. So, E of NQ by probability of N greater than 1. So, probability of N greater than 1, it means simply 1 minus probability of N less than 1. Less than or equal to 1. Correct. So, it is 1 minus P naught minus P1. Correct. Yes. So, it is simply E of NQ you know already, because it is MM1 model. It is lambda square by mu into mu minus lambda is the E of NQ into 1 upon, because this is in the denominator. Okay, 1 minus P naught minus, what is P1? Right. So 1 minus P naught minus P1. So P1 you know already. You know Pn is equal to what? Lambda by mu whole to the power of n into P naught. Correct. So you put n is equal to 1. You will be getting lambda by mu into P naught. Simple. So you take P naught out, you will be getting this one. Yes. So after you simply series of simplification and solution, you will be getting 1.5%. Now, if you are having an interest, you straight away find what is E of NQ. It will not be 1.5%. So, I'm telling, so for this question, you are finding E of NQ, then it is completely wrong. You have to find E of NQ provided that average length of a queue that forms time to time. So they are not asking just average length of queue, that forms time to time. Forms time to time means queue should form. When queue will form? When there are person in the queue, then only queue will form. Correct? Okay. I hope this is clear. And if you have exclusively doubt again on this particular fourth part, you can take screenshot and ask at the end of the session. Okay. So let me go with the second question. There were two questions in your previous year paper. That means like ninth month and 10th month, one among that. So here again, this one was asked as a 7-mark question. So this was direct actually. One man barber shop, interval type 1 by lambda and 1 by mu is given. So they are asking LS and LQ. First one you can only solve. So calculate the percent of time an arrival can walk straight into barber's chair without having to wait. Okay. So he can walk straight away. P naught, correct. There are no customers. Okay. How much time can a customer expect to spend in the barber shop? Is it not WS? You can find directly. So what is the average time customer spends in the queue? Yes, you can find WQ. Yes, average time customers spend in the queue. Okay, so I'll be just going because I have told what is the hint for you. This was, in fact, much easier question in your previous year paper. So you can find 1 by lambda, 1 by mu, yes, everything. So you can get the answers like this. Yes, E of WQ, you are done. Okay, as thank you pages come, you taking that time for explaining some practicality where you need to come up with this queuing theory. You need to apply that. Okay, so that I'll be taking up for next 5 minutes. Then you can extend it for other 10 minutes for doubt clarification. Okay, I'll be opening the whiteboard. Oh, sorry. Yeah. So applications. Okay. See, in queuing theory, it is not like some other topic for you could ask for application, because queue is formed in it as like a part of life. I told when I started the session, I told queue is a part of life. That means everything you see across is nothing but queue, correct? So that means it is having everywhere its application, correct? You go to post office, bank, you will be finding the queue. So there will be two different queue lengths, I told. So first important thing is to choose which is better for you. So the major application of this queuing system is that you can able to, by using the queuing system. I know in the practical case it is not possible. Like you open your book and start solving by seeing the queue, and you can't measure the time and think that which is better. Okay, it's the thing. But for analysis purpose, or if you are dealing with majorly in the field of business analytics, so they can take the business data of like 1 month or 1 week. What is the business data? How many customers are coming? So for the customer, how to provide the better service. So for them, this is important. They need to calculate. So that's where this application comes. For a general public, for waiting in, I took the last previous problem. There it was 0.5 hours and 0.5236 hours, correct? See, this 236 will not make that much sense, correct? So you choose this or this. Both mean the same in your practical application. So this is not same for the one who is doing the business, correct? So usually the commodities, there it is not customer, there will be the commodity. So for that consideration, so you need to take it as an application. The second one, what is the second one? So you need to know whether you are in a loss state or you are in a profit state. So whenever you are in a business system, whether you're in a profit state or loss state, you will know based on your customers as well as your capacity utilization. The capacity utilization rho is very important in this case. It is lambda by mu. Okay, so it is arrival rate to service rate ratio. See, if your arrival rate is more and your service rate is less, it means you are taking more time on your customer, thereby you are losing customer. So this is what I wanted to tell, so I kept it for a last day. Okay, so you're losing customers. Okay, now say for example lambda by mu, your lambda value is less, mu value is more. That means you are not attracting your customer. You're not attracting the customer. See, both are, is it not a drawback for your business? Yes. So you need to set the priority of your capacity utilization in such a way that it will be beneficiary to you. Is it not a better application? Yes. So this is the case. So next, third and final one which I can tell is data interpretations. See, data is everything in present world. Okay, so even in our software which I have learned, we did only thing is we are dealing with the data. That's it. So data interpretation is everything. So in the data interpretation, see, if you are getting a lot number of data arrivals, and you could not just get connected in such a way that you could not serve that data in a proper manner, then you miss the data, or there may be a lot of burdeniousness in your data. So in that case, what you have to do, by the queuing system, you will get to know that you are slow in analyzing the data or interpreting data. Then you can able to improve yourself. From manual data interpretation, you can go data interpretation using Excel. Okay, if it is still yielding you with a less efficiency rate with the help of this queuing model, you can go with some programming softwares like R, C+, or something, etc. Is it not? So this is how you can implement yourself. This is how you can decide yourself that how you need to deal with the customers. So not there, it was not customer, there it was data or something like that. So how to deal with some arrivals is very important phenomena when you need to run your system in a proper manner. So these are the three major important applications. So, and you want industrial applications or some real-time application, you can find everywhere, I told. So if somebody asks me question that what is real-time application, I will tell waiting in a barber shop, waiting in tea stall, waiting in post office, railway station, something. These are all applications only. So what is the sector of application? That is these three which I have been listed. Okay. So hope these 3 days session was informative, and you really enjoyed in knowing. See, we can't enjoy standing in queue, but we can enjoy learning the how the queuing system will hack. Correct. So thank you. So this was from my side. If you have any doubt, you can ask. So thank you.
Gunavati? Hello? Gunavati? Hello? Gunavati? Anybody have a doubt, free to ask the question. We are sharing a feedback form within a second. Anybody have a doubt, free to ask the question. Yeah, Gunavati, please share the feedback form.
Yes, ma'am, doing it. Dear all, you can find the feedback link in the chat box.